Alright, welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, we are still looking at the MachO symbols. We need to get an understanding of this stuff. So right now, I'm not sure if it's a good idea to so what I've done in previous videos, like look at the raw data we pull in with leaf and then try to figure out like how we use it. But maybe that's not the best way. Maybe there's some documentation, some C headers that give better clues to get started on this, because this try and error and trying to figure out this is not good. So I do wanna okay, how about we say I have a the suggestion is I have a favorite recipe for chocolate chip cookies. Why? Why would that be my question? I have a executable. I have a MachO executable with symbols. I can extract those. I can inspect those symbols with leaf in C++. I would like to make sense of how to interpret the different kinds of symbols. Are there any resources or libraries that can assist with that? Let's see. Can be complex, but there are resources and libraries. MachO file format documentation. Apple's official MachO documentation is a good starting point to understand the structure. Okay. Leaf documentation. Leaf library provides API to parse and analyze MachO files, including symbols. Yeah. Source code examples. Apple's open source DYLD provides insight into how symbols are used in dynamic linking. Okay, that's news. llvm MachO support. llvm tools like llvm read object, llvm nm provide utilities for inspecting symbols in MachO files. Okay, use leaf to parse MachO file and retrieve symbol information, including their types, attributes, and bindings. Symbols can often be classified as external, static, undefined. To be resolved at runtime. Capstone. For analyzing functions associated with symbols, use disassembly libraries like Capstone or Zydus. MachO view, a GUI-based tool to inspect MachO binaries. NM and O2. Listing symbols. Section apps. Visible outside the binary. Oh boy. Symbol demangling. Okay, we already have the symbol demangling covered. This DYLD loading, I hear about this. Well, I've seen traces of this, but I have not really inspected this yet. Study how the dynamic loader, resolve symbols. Dynamic loader, but is this relevant for us? We are not really working with linked libraries, with dynamic libraries. It's a monolithic executable, so I don't know if this has any relevance at all. Maybe not. Yeah. Okay. Okay, that's quite some information. Okay, so there is a MachO documentation. Let's take a look at that. Okay. Building MachO, executing, loading code and runtime, indirect addressing. Launching, forking, finding, scope and treatment. What? Scope and treatment of symbol definitions. Okay, I don't know how that helps. Finding imported symbols. When the dynamic linker loads a MachO file, it connects the file's imported symbols to the definitions in a shared library or framework. So, leave documentation. Let's look at this one. Okay, why can I not open this? It's not a link. Huh. What is this here? Apple open source. The page you're looking for can't be found. Okay. Well, llvm tools. What is this? Read object. llvm read object. What is that? Object reader. Low-level format specific information about one or more object files. Demangle, decompress. This option is only for ELF and XC of MachO specific options. Indirect display, indirect symbols. Okay, read objects. Okay, and then there's this NM. What is that? llvm NM. List the names of symbols from llvm bitcode files, objects, files, and archives. Each symbol is listed along with some simple information about its provenance. Oh. Okay. Okay, these two tools. Okay, are these part of the redistributable that we have installed? llvm here 19.1 bin. Let me see. What was the name? Read objects. llvm read objects. Here, this one. Okay, so let's open a command prompt. Let's go to so we go into this folder here, cd in here, and then we run this. Yeah, this and llvm -read object.exe. And now the question is, what kind of command lines? There's also a read elf. Read object provides t symbols. Okay, what do we need to pass? Do we need to we need to pass a file, very likely. File, add file. Read command line options from, oh no. How do we say it will read from the specified file names? Options input. So I guess we just give it like ZH, right? That's our file name here, ZH. Let's see what it says. Ah, okay, hold on, we made a mistake here. There we go. Okay, so it's a MachO 32-bit, yeah, PowerPC, yeah, Titanium, yeah. Okay, so what can we do here? Minus minus all, what is that? Yeah. Oh boy. Can we? Yeah, stop. Can we perhaps? All. So let's output this into a llvm read object dot txt. Okay, read object minus all. Okay, let's do that. Okay, that's done. Let's see. Sections. Okay. Okay, this one. Yeah. Ref type flags value. think it would be interesting to output this with demangled names. So there was this option. Data encode command. Indirect symbols. Linker options. MachO linker options. Okay, how about we do a demangle? Display demangled symbol names in the output. Let's see if that works. Minus demangle. Demangle, and then here we do minus minus demangle. Okay. Let's see. Okay. The size is the same. Now the question is it demangled? No, it is not. No. Okay, so the demangling doesn't work here on this one. That's okay, let's delete it. I'm interested in those MachO specific options here to just see what this does. So I would like to see what this gives. And we put that into read object. Okay, let's see. Okay, that gave nothing. Oops. Display the data encode command. Okay, how about we do without file outputs? Minus minus MachO dsym tab. What does that give? Error. Okay, dsym tab. MachO minus dsym tab. Did I dsym tab? Did I misspell it? Ah, dy. There we go. Dy. No. Oh, it's incorrectly written in here. Look at that. What is that? Okay, let's output that into a file. Copy that. Okay. MachO. Okay. Let's go for the next one. This one here. Okay, let's go for the next one. All right, MachO, Android symbol. There we go. There we go. MachO segments. Okay. There we go. And MachO version min. Let's see. .txt. Yeah, okay. Okay, there we go. Okay, let's have a look what this generated. Okay, so this one is not particularly useful. This one, what is that? Local sim, under some indirect sim of, okay. Power PC. Okay, what is this here? Indirect symbols. Number. Okay. Indirect symbols. Number. Okay, how many of these numbers are there? 1, 2. Okay. I don't know what indirect symbols means, but okay. Linker options. That's interesting. Oh, doesn't show anything. Okay. Segment. Okay. And what is this? Nothing. Okay, well, there's some information. Not sure what to do with it, but okay. Good. Not sure if we can get more from this tool here. But it's not particularly useful so far. I wonder if there's anything else. Contents of the string table. String table. Let me see that. String table. Yeah. Let's see. 1 kilobyte. Okay. Nothing in there. Okay. Symbols. Display the symbol table. Unwind information. Stack map. String dump. Okay, when we look at this one here, it would be interesting to see. So there's only the section and symbol. Section and symbol. Yeah. So I wonder how many symbols are there. Let's search for this here and press count. It says 402,000 symbols. This is interesting because here in our JSON, let's search for category. That gives 370,000. 370, so it's 30,000 less here. I don't know if that's a problem. Maybe this one just shows some things as symbols which are not really of interest for us. I'm not sure. Let me see. Are there any sim debug table? There's that. Undefined. I wonder if this is something that 24 type. Oh, here we get some section. This type. Oof. That's a good question. Why are there more symbols in here? Is this a reason to worry or not? This one also reports around 370,000 symbols and not 400,000. I wonder where the 400,000 comes from. Maybe it's this plus this 40,000. Yeah. Yeah, maybe. I don't know. Yeah. Okay, we can. Well, maybe what we can do is we can take some. So, for example, we look at this guy. We take this our JSON here, put that here, and we search for this guy here, and it's here, and it's extremely laggy. Let's open it in Visual Studio Code. That's faster. Let's move this down here. I think it's slow because of the coloring. That's my guess. Maybe we can say none. Maybe it's fast now. Maybe a bit. Okay, so what's happening? Okay, this one is slow as well. Jesus Christ. Let's just do it here. Okay, so this one has three times this entry, and this one has it just twice. Look at that. Huh. So raw type 38.eh. Huh. So this one here is not part of this one here. Why not? Section text. I don't know. Okay, so it's already a difference. Read object all. Interesting. I wonder if that's because it shows more symbols from here, from the PowerPC portion. So somehow it has two portions. It has this portion here, and then it has this portion. I wonder what's up with that. Yeah, I don't know what to say about this. Good. But other than this, I don't know if we can get anything else from this. Okay, let's try this other tool. Names of symbols. Absolute symbol. Show all symbols. Yeah. Okay, let's try that then. So this is llvm nm. Is this part in there? Let's see. nm llvm. Yeah, it's here. Okay. Okay, then let's go. Let's start with the debug sims. Debug sims. And then we put it into a nm and here into debug sims. Let's see. Okay, that took a while. Okay, it outputted something. Let's see. Okay. Okay, I don't know what that is here. Huh. What the hell is that? What the hell is that? Oof. Jesus Christ. Huh. This one looks weird. Why is this labeled as a function? This looks like some static variable, right? This doesn't look like a function. That's strange. So this one also lists 400,000 entries. Roundabout. Worker shoe template. Aha, so this function, they have no name. We have seen this in our JSON as well. Functions without a name. Maybe they are functions, but they simply have no name because maybe they are inlined or something. Yeah, 0.5. What does it 0.5 stand for? Maybe it's a size. What is SO? I don't know. Fun. SO. I don't know. SOL. Source object, maybe. SO. Yeah, I don't know. And what is this number here? Is this like a size of the function? The byte size? Maybe. Yeah, so what I can imagine here with those functions, I mean, it makes sense. 5 bytes would be the minimum size a function can be if it's just a jump. A function and it just jumps somewhere. So it has to be at least 5. Jump is a jump instruction plus 4 bytes for the address, right? So it makes sense that the smallest function would be 5 bytes here. Yeah. So my suspicion is that these are just inlined functions. Or yeah, function. But why would they have no name? How many are these here? Let's see. Oh, it's a lot. Let's see from down here. So this is. So it's 122,000 roundabouts. To okay, so around 122. This is 32. So what is it? 90,000. Around 90,000 functions without names. Oof. 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 I guess, I mean, 90,000 functions without names. I mean, this is not very helpful. Yeah. 90,000. Well, it's not like that we can do anything with it. If it doesn't have a name, we don't know where it belongs, right? So this might be useless information here. Okay, so my takeaway here is that we have 370,000 symbols in the Itanium portion, and 30,000 symbols for some reason in another portion of the executable for PowerPC. But why? Why are there two different? Why are there two executables in the Mac ZH? Let me get the proof here. Where was it? There. This one. So one time PowerPC plus one time i386. Okay, let's get back to the NM tool. Print only symbols defined in this file. Defined only. I don't know what that does. Dynamic. Display dynamic symbols. Minus export symbols. What does that do? Let's get that. Export symbols. Export symbols. Okay. Okay, where are we here? Extern only. Print only symbols whose definition are external. Okay, well, that's... I don't know if that's particularly useful, but we can do it. Extern only. Extern only. There we go. Let's see. Extern. Okay, next. Help, line numbers. Undefined symbols have the location of the line numbers. So if we do here debug sims minus minus line numbers, what will this do? Let's do here minus line numbers. Looks like it did nothing. Yeah. Okay, what if we just do line numbers? What does that do? That did something. Use debugging information to print the file names and line numbers. Okay. Okay, so yeah, I don't know how helpful this really was now. I don't know. Apple's open source DYLD provides insight into how symbols are used in dynamic linking. Parse and analyze MachO files, including symbols, extracting and interpreting symbol attributes. Symbols can often be external, static, undefined. Capstone. Disassembly. We're not really interested in disassembly much. I'm not sure. Apples NM and O2 listing symbols. DYLD loading. Okay, so let's see. DYLD library. It's GitHub. Apple open source DYLD. What is that? Okay, 5 years ago. It's kind of weird that they haven't touched it in a long time. The question is, what does this do? Source, image loader, MachO. Oh boy, they have assembler in here. What the? Oh boy. Oh boy. Thread local helpers. Oh my gosh. That is hardcore. Okay, so what does this do here? Image loader. Oh boy. Oof. Oof. Contains symbol. Yeah, I don't know what we can use this here for. I mean, obviously this is a real deal because it's directly from Apple. But what would we do with that? I don't know. I don't know. Maybe it just would provide us the same stuff that Leaf already gives us. I don't know. Yeah, I do wonder if we get more information from this here, but I don't even know where to start looking for. A lot of tests, yeah. Image loader. Image load. Oh boy, all these function pointers here. Jesus Christ. Boy. Jesus Christ. Pass. question is, what can we do with this thing? I don't know. I don't know. Version of runtime. Main executor is linked against. How about we ask ChatGPT, what does the DYLD, what does the DLD do? Dynamic linker, dynamic loader is a critical component of macOS and iOS that manages the runtime linking of executables and shared libraries. Runtime linking. Okay. The linker. Shared libraries. Its primary role is to prepare a program for execution by resolving dependencies, loading shared libraries, and binding symbols. Okay. Loading dependent libraries. When an executable is launched, DY-loader reads the list of shared libraries it depends on and loads them into memory. Okay. Relocating libraries. Dilibs are typically compiled, allowing them to be loaded to different memory addresses, relocates them in memory. Okay. Symbol resolution and binding. DYLD resolves symbols, functions, variables used in the program and maps them to the correct locations. Resolve symbols and maps them to the correct locations. Lazy binding, pre-binding. Okay, so this one looks to be of interest here. Resolve symbols used by the program, maps them to the correct locations. But is that all it does? Associated load commands. Identify all and loads all required dilibs, handling version checks and resolving any potential conflicts. Binding symbols. Matches undefined symbols in the executable with the definitions in the dilibs. Depending on the settings, this process may occur during startup or on demand. Operates directly in the MachO binary format, interpreting sections and commands. Shared libraries to load, defines a symbol table, contains dynamic symbol table information for runtime binding. DYSymTab. Dynamic symbol table. Provides tools and options to debug and analyze dynamic linking issues. Oh boy, ensures it can run by dynamically linking it to the required libraries, resolving symbols and setting up the runtime. Okay. Symbol resolution and binding. Can you explain? Can you elaborate on symbol resolution and binding? It is not entirely clear to me what all this entails. Central process dynamic linking, ensuring that symbols, functions, global variables, reference, and program are correctly matched to their definitions at runtime. Let's break it down. A symbol in this context is a named entity in a program, a function, a global static variable, a section label, or address. Yeah. Symbols are defined in libraries, shared libraries, or dylibs, always in the executable itself. Yeah. And they are either defined symbols represented by actual code or data, undefined symbols referenced by code but not defined within the same file. Undefined symbols referenced by code. Hold on. Defined symbols represented by actual code or data. Okay. Undefined symbols referenced by code but not defined within the same file. A call to printf. Okay. I find this confusing, this explanation. Referenced by codes, but not defined within the same file. So just a reference. I don't know why this is called undefined symbol. I don't see the connection. It's a referenced symbol. Why is it undefined? Symbol resolution is a process of finding the correct definition for an undefined symbol during program execution. This involves matching the symbol name with its corresponding definition in the available binaries, the executable or lower shared libraries. Symbol lookup. When the program refers to a symbol, calling printf, dyld searches for the symbol in the following order: the executable symbol table, the symbol tables of dependent shared libraries in load order. If the symbol is not found, dlyd may produce an error like symbol not found. Scope of search. Symbols can be local, private, or to a binary, or global. dyld follows specific rules to determine visibility based on symbol attributes. A symbol in one library can be overridden by another library loaded earlier. Symbol binding. Symbol binding refers to connecting the symbol reference, the call site, the symbol reference, the call site, and the code to the memory address of the resolved symbol. This ensures that when the program executes, the symbol points to the correct implementation of data. All dependencies are available up front. Reduces startup time by deferring work. Blah. Okay, that's just optimization. We don't care. The call first jumps to a stub in the executable. The stub points to resolver. dyld resolves the address of printf. The resolver updates the stub with the correct address. Symbol table. Dynamic symbol table. Let's see. This, hold on. Do we find this here? No. Do we find this here? LC sim tab. Yeah, that's here. Do we find this one here? No. Dynamic symbol table. Duplicate symbols. Finding the definition of a symbol, connecting reference to the reserved address. Yeah, I don't know what question I should ask. Thing is, we want we want to okay. How should I approach collecting? Okay, how about this? I want to collect all symbol information from the MachO. I want to collect all symbol information from the MachO to rebuild C++ code, code as far to rebuild as much C++ code as it possibly can. How to rebuild as much C++ code as it possibly can. How do I approach implementing this? I don't even know what to ask, man. Let's see what ChatGPT says. Rebuilding sim from MachO is an ambitious project, but feasible to a degree, depending on the richness. Yeah, and debug information in the binary. Here's a structured approach. Before implementation, it's crucial to identify the type and scope of data available in the MachO file. Yes. Symbol table contains function names, global variables, and their attributes. Yeah. Debug information optional. If the binary includes dwarf data, you can extract detailed information like types, function signatures, and even source file locations. Function disassembly. For stripped binaries or missing debug info, you may need to disassemble functions to infer the structure. Dwarf dump. Parse and extract symbol tables, sections, and segments. Okay. llvm clank. llvm dwarf dump for extracting dwarf debug info. llvm libraries to generate C++ code structures. Okay, the demangling we have sorted for the most part. Yeah, well, this one we probably won't be doing. Symbol tables, sections, relocations and bindings. What do I do with relocations and bindings? Didn't we see this example already before? If dwarf debug info is present, use LM's dwarf dump or libraries like libdwarf to extract class and struct definitions, function signatures and parameter types, source file and line number mappings. Okay, what is this dwarf dump? Let's see. Do we have it here? llvm dwarf dump. I don't see it. PDB util dwarf dump. I don't see the dwarf dump. Let me see. llvm dwarf dump. Why does this executable not exist? llvm dwarf dump. Dwarf dump Windows. Dwarf dump. Dwarf dump. Does it maybe have a different name? I don't see it. Dwarf dump. Dwarf dump. llvm dwarf dump Windows downloads. With missing binaries. Dwarf dump. Why is this not in here? llvm dwarf dump. Maybe it's not part of the Windows redistributable Windows build. Maybe it's only on other platforms, which would be a shame though, but I can't. What is libdwarf? Libdwarf. Dwarf dump. llvm dwarf dump. I don't know. Looks like we don't have it. Class and struct definitions. Yeah, I would like to see this. Main. Symbol mangling, yeah. Code reconstruction. Heuristics. Yeah. Are there other tools? Are there does llvm dwarf dump is llvm dwarf dump targeted for Windows? No. Cross-platform, yeah. But dwarf on Windows. On Windows, private debug format is PDB, not dwarf. Using on Windows. Can be compiled, executed on Windows. Its usefulness depends on the availability of dwarf data. Yeah, I just want this tool on Windows. Ugh. dwarf dump. Okay, I understand, but where do I find this tool then? llvm dwarf dump precompiled. What about the other llvm installation? Is it in here? llvm. No. Nope. This. What about this? The WP. What is this? Help. WO. There's a typo here. Overvolves. Programmers cannot type. Dwarf dump. Yeah. It would be interesting to use this. Dwarf dump Windows. What is that? Source codes. Okay, I wonder we should give this a go here and just see what happens. But this is probably not for Windows here. Right. Dwarf Explorer. Dwarf dump. Dwarf dump. Dwarf Explorer. What is that? Is this for Windows? Runs on Windows. MachO Dwarf Explorer. Okay. Okay. Let's download the source codes. Let's just put it in here. Make. Okay, let's unzip this. Okay, what does this do here? Make. What? Python. It's a Python tool. What the hell? Oh, that's wild. So what does this do? Jesus Christ. I don't trust this thing. This seems weird. This seems weird. Yeah. I don't like it. Let's delete that. Yeah, okay, so we want to get hands on a dwarf dumper. Dwarf dump tour. What about this one here? Lip dwarf. What does this do? Dwarf. Oh boy. Crablicious. What? Crablicious. Okay, so what do we do with this? Releases. Lip dwarf. Oh, it's a tar.xz, which I can't open here. Actually, hold on, maybe 7zip can open it. Yeah. Yeah. Luckily. Okay. Oof. So it uses CMake or what happens? There's a CMake list. Let's see. CMake bin. Lip dwarf. Let's see. Configure. Build directory does not exist. Yes. So Visual Studio 17. Yeah, 17. Finish. Let's see what this does. Okay, let's generate. Okay, that has worked. Solution lip dwarf solution. Okay, let's open that bad boy. Okay, there's a dwarf dump tour. Okay, let's compile release build solution dwarf. Okay, so far so good. Yeah. Okay, it's C code. Oh boy. Dwarf. I have highest respect for people who code in C because C is hard. It's harder than C++, I would say. C++ gives you all these nice language features, and C gives you nothing. C gives you absolutely nothing. Well, it looks like people have no problems programming in C until they corrupt the memory. Okay, so this has succeeded. Then let's check it out. Where's it? Here. So we've compiled release, and it's not here. Where's it? Where did it compile to? Source bin. Huh? Jesus. No. Solution source bin. There we go. Release. Okay, that's a very suspicious location. Okay, let's copy this tour. Put it somewhere else. Let's put it here for now. Or we can put it into the MISC folder with other trash already. Dwarf dump. Let's do cdd no. So we go here, dwarf dump. Let's do minus help. Yeah, okay. Oh, so much. Holy shit. I want the simple usage. Where are we? Here. Dwarf dump options object file. Oof. Print all. Print all. Yeah. Does nothing. Was never very useful. Okay. Okay, so how about we do, oh shit, what was it? Print all. Print all. Okay. Print all. So looking at ZH, and we output to data. We output to ZH dwarf dump print all.txt dwarf dump. Okay, that's did nothing. Error. Huh. No dwarf information present. Configure errors. Error. What is dwarf dump.config. Let's put it, but I mean, this one doesn't look very good here. No dwarf information present. Jesus Christ. Yeah, here. So this config file, where would that be? Let's search for dwarfdump.config here. There it is. Dwarf. Okay, let's copy this guy. Let's put it. Jesus Christ. Projects, assembly, MISC, in here. There we go. Okay, let's try executing this again. At least I would like to get rid of this error. No dwarf information present. Oh, that's unfortunate. What would that have given us? Let's see. Dwarf. If the binary includes dwarf data, you can extract detailed information like types, function signatures, and even source file locations. Okay, so it doesn't have that. Yeah, okay. Parse a MachO file. So I wonder, what about this relocations and bindings? How is this helpful for us? Relocation and bindings. Does it mention it anywhere else? Relocations. No, it only mentioned it once here. You did mention relocation and bindings previously. What does this entail? Crucial concepts, dynamic linking. Okay, but do we need dynamic linking? Runtime symbol resolution, ensuring that code and data are correctly placed and referenced in memory. Code and data are correctly placed. Relocation are adjustments made to code and data reference in the binary so they point to the correct memory addresses at runtime. Okay, but we don't run this thing. We don't do runtime. Absolute memory addresses are usually not known. Placeholders or offsets are used, and these need to be updated when the binary is loaded. Okay, we don't care about this. Position independent code, external symbol reference, we don't care. Dynamic linking, we don't care. A function, a program calls an external library function, we don't care. A call instruction, okay, we don't care. Relocation entries. A relocation in the binary that needs to be modified. Each entry specifies the type of relocation, absolute, relative, or God. This offset or address in the binary where the fixed sub is required, the symbol or reference that the relocation depends on. Relocation and MachO. Relocation entries are stored in the data segments. Okay, we don't have any llvm tabs. Compile time. Eager binding. So to me, it sounds like we don't care about relocations because we are not actually loading. We're not going into runtime. We're only looking at what's in the executable, right? Okay, so we don't have any dwarf data. I guess that's bad news, but yeah, we kind of are aware about what we have. We just need to understand it, need to work with it. Okay, I think we are none the wiser. Not much. Yeah. Yeah. Okay, what's the time? Yeah. Good. Yeah, I think I will take a break here. I still have more questions than answers, so we need to dig more. Okay, but we learned some things here. We used some tools. We now know that there's no dwarf data. We know there are 400,000 symbols with 30,000 in the PowerPC portion and 370,000 in the Eternium portion. I don't know why. Let's see if there's any answer. That's because it runs on both platforms. It runs on Mac PPC and Mac x86. A fat binary. The code is compiled for various platforms when a final tool called LiPo is called. Okay. There are 30K symbols in PowerPC and 370K in i386. For some reason, Leaf gives no symbols for the PowerPC portion. I wonder if that is a problem, if that is a detriment. Okay, let's also share this stuff here. Let's put it here to a zip file. 8 megabyte, yeah. Let's delete this. llvm dwarf llvm dumps. I did some dumping with llvm reads objects llvm nm and dwarf dump. I think there are no big relevations. Sadly, the executable has, well, I don't know if it's, yeah, probably sadly, the executable has no dwarf data. Revelations. Good. But we have some dumps. That's good, I guess. Okay, good. Good. Then, yeah, next session, we try to investigate more. Try to get to the bottom of the symbols. I mean, there's always the option of trying to figure out everything on our own, right? Like what I have done in the previous session a little bit. But the risk there is that I won't discover everything and eventually miss some information, some crucial information, and then maybe have very bad quality of symbols because I didn't gather everything. That's a risk, right? So it would be good to get something official where, a library that has all the stuff figured out correctly and we just use it, and there's no big risk of missing some information because it's all done to spec. I don't know. It's really difficult, I have to say. Yeah. Good. So, yeah, we just need to keep looking, keep studying, keep looking. Eventually, we will figure it out. Yeah, maybe. Good. Then, yeah, I will take the break here. I wish you a great day or night. Until next time. Goodbye.